In this video, we talk about the nervous system, orchestration and RAG, the manager LangChain, core primitives of LangChain, chains and agents, with and without LangChain, LangGraph, and the popular frameworks. This is the third video in the video series of AI jargon in simple terms. We already covered memory and hands in the earlier two videos. Here we'll be covering the nervous system or the orchestration and RAG. Let's get into the slides. Let's come to nervous system. Nervous system is where it is coordinating between the memory and hands, orchestrating between memory and hands and other resources and tools to create a complete digital worker. The most commonly used open source system is LangChain. This can be somewhat compared with WordPress, which is used for web development, where you have a lot of ready-made components, website components, website APIs, connectivity. Everything is readily available to create a website very quickly without writing too much of code. Similarly, LangChain is a framework which is used to create the AI systems, or the complete digital worker, which can be done with a very less code, by writing very less code in that, which has many components in it. Like say we have chains, agents, tools, retrievers, prompts, and callbacks. So what exactly it does is it does a workflow coordination wherein it knows what is the status of the earlier task which is done. It knows the state, or it has some kind of memory to understand what is the current status of the work, and then it prompts along with the status, along with the lost status, it prompts the required information into the LLM to work on the task, to think, and based on the output from the LLM, it helps in connecting to the required API or to any other tool to complete the task as a digital work. So let's understand core primitives in little more details to know which are the components inside LangChain which is helping in creating this digital worker. The core primitives are chains, agents, tools, retrievers, prompts, and callbacks. So coming to chains, we can say, like say, if there's any predictable linear workflow is there. For example, if there is a form has to be filled, if form is filled, it goes and saves into a database. That is one chain of action. So these kind of predefined chains are available, which can be directly used in while creating the digital worker. When it comes to agents, we can say these are the plug and play AI managers who knows how to think, decide, and act based on the predefined logics and without writing too much of code. So that is a very crucial part, which helps in creating a digital work. When it comes to tools, they are LangChain scalable actions wherein we can use it for summarizing any report or creating a graph. It goes and calls a particular Python functions or APIs or maybe the searches so that it can go and fetch the right data and perform the real world actions. Retrievers are a controlled on-demand access to the company's actual data, which it picks out as and when it is required without doing any guessing. It helps in giving the right information while carrying out any company-related activities. Prompts are nothing but the standard instruction LLM prompts. It contains AI roles, the actual task, what is the context, and how to process it, and what are the constraints and the output. All this put together in a well structured prompt, which are available to use by just changing a little bit of variables here and there. These prompts can be directly used. It gives best output. It helps digital worker with the right information to do its next task. Callbacks in LangChain provide observability and control hooks that let teams log, monitor, debug, and audit AI workflows at each and every step. Let's go to the next slide. Chains versus agents. Chains and agents are the two most critical components which is used for creating any digital worker for any businesses. Chains are a linear flow where it is you have an input and this output very well defined. It is linearly defined. Like say for example, as I already said, if form filling is done and it goes and stores in the database. And the second example is like say if there is a FAQ query, the answer is very standard. The standard answer is given back. So that is a linear flow. When it comes to agents, basically we have like say if we have to give a loan if the loan has to be given, it can go and check, whether how is this pattern of the loan is already, he's been paying regularly, not paying, whether he's eligible. All that it checks, it takes a decision, and then it gives a approval. Oh, this loan can be given on. These are the two main components for any agentic AI or digital worker, which can be used in LangChain with a minimal coding. Let's go to the next slide and see what is the advantage of using LangChain in creating any digital worker. First one is unified model abstraction layer. Basically, we can connect to any LLM very easily, changing from this LLM to other LLM, from ChatGPT to Gemini or to cloud is very easy. So second is structured and reusable prompt templates. It has very good prompt templates to give very good desired outputs. Tool and multi-model orchestration. Like say if we are connecting to video, audio, or a PDF, when it comes to without lang, we have to write code for each one of them, parsing all this data. But here you have a document loader, kind of thing, which takes care of all this, and you have multiple components, which it's almost like a plug and play. It does all that with the minimal efforts. It can be done. Coming to state management, LangChain maintains a structured workflow on the current status of the data, or like say what is the output of the earlier workflow, what is the output of some of the API calls being done. So when you have a multi-step process, it helps in orchestrating very efficiently on the current status of the data, so that it reaches the goal of a digital worker in this multi-workflow environment very efficiently. Coming to standardized RAG building blocks. RAG is Retrieval Augmented Generation. We'll cover this RAG system completely in next video. Basically, it has four components, like say the document ingestion, then retrieval, augmentation, and generation. All these components are available in LangChain. Or like say for example, document loader. When you're trying to add documents into the system, it splits the document and stuff. And then you have a retriever. We already covered retriever in the previous slide. Like that, the components are already available. We using that. This RAG system can be built very quickly with a minimal coding. Coming to production-oriented AI architecture, it is actually a nightmare to create any APIs. If you have multiple APIs or components you're calling in any system or in any software, for it to work without errors. So when it comes to LangChain, it has streamlined all of them with a standard structure, so that whatever is done, it is always almost production ready, which can be implemented, which can be deployed easily with a minimum errors, basically. So let's go to the next slide. The reason for knowing LangGraph is because the use cases of LangChain, in most of the use cases is they're used for linear agentic flow, where when any input is given and any analysis is to be done, any monthly analysis to be done every month or something like that, the LangChain is something which is preferred. That's a basic example. But when there is a cyclic agent is there, like, where when any input is given, it has to take a decision, and it comes back to the loop and checks with another agent, or where the state management is managed in the complex workflow. In these cases, LangGraph is used. For example, in the previous video, we have discussed about the robot delivering towel to the customer in a large hotels. In these kind of scenario, LangGraph is used. So let's read out what LangGraph means. It's an open source framework from LangChain designed for building stateful agent-based AI applications using a graph-based architecture. To just quickly, go through this, how LangGraph is actually used. Is it contains nodes, node 1, node 2, node 3, node 4, and it contains edges. It's like loan application submitted, pass, all these called as edges and the nodes. And there is a state management. There is state, it knows the status of what is the status of eligibility of KYC check or something within this node 1. So this is how the LangGraph works. Basically, if you're looking at the person submits a form, loan application is submitted to understand whether he's eligible for loan or something. Node 1 checks the eligibility or KYC check. Node 2 check the credit risk assessment, And if it is a high risk, it takes a decision and it ends, it rejects it. If it is a low risk, it is good, then it goes for a final approval. Or if thinks it is a medium risk, it goes to the manual review. So this is how the cyclic agentic AI flow is managed in LangGraph. Let's go to the next slide. So these are the popular frameworks currently which are in use. Like say you have LangGraph, Crew AI, Llama Index, AutoGen, and Haystack. Go in detail in the upcoming videos based on which scenario, which framework to be used. Just to give one example, like say if you have the robot delivering towel snacks to the customer room in restaurant, as we discussed in the earlier video, the best fit for that is LangGraph. Like this is excellent, high reliability because it is a cyclic graph. Orchestration style is a cyclic graph, and then whereas this llama index is event driven. So if it is good only if the data is heavy. If data is not heavy, it is not good. And autogen is a chat based orchestration style which is harder to control. Like say it might not be a good fit for this kind of scenario. We can discuss these frameworks in detail in upcoming videos based on the scenario, based on the business need. In the next video we talk about RAG, which is Retrieval Augmented Generation, in detail. I hope this video gives some clarity about the LangChain and the orchestration of the AI system. Thank you.